Hi everyone, I've been wanting to put together this video to go through how to set up a Matek ELRS receiver to work with your radio control glider. Today I'm going to be using the Matek ELRS R-24-V receiver that's got a built-in Vario and altimeter. Looks like this when you get it in the packet. So we'll go through some of the different steps for getting set up with these receivers. ELRS is quite complicated. There's a bunch of steps that we'll need to go through in order to get this working, but the performance is awesome. So I think if you're someone who's not afraid of getting a little bit technical and doing some manual setup, then it's definitely worth it to give ELRS a shot. If you're somebody who's not very technical, I would suggest giving ELRS a miss for now. There are a bunch of different stages. It can be tricky to work through all of these, and you'll need to be on top of all of this stuff for your system to work properly. So other alternatives to look at might be Crossfire or one of the FreeSky systems instead. So we'll be going through the setup in a few different areas. We'll take a look at setting up the transmitter module and getting ELRS updated on there. We'll also take a look at adding the Lua script for ELRS to your radio. That will let you do some basic tasks like binding and adjusting some of the configuration directly from your radio. We'll also look at updating the ELRS receiver, as well as updating the Matek PWM board. And this is probably a good time to mention that the receiver in this case that we're looking at actually has two parts. So there is the ELRS receiver, which sits on top, and then there's a PWM adapter board underneath, which takes the signals and has space for PWM output pins that let you connect your servos directly to the receiver. The ELRS technology came out of drone equipment, so those guys aren't typically using PWM outputs and servos on their builds, but it is a very helpful thing that we've got this great long-range radio technology and now a way to use it in our gliders. I'm going to take a look at what setup is required for the transmitter module. This process will be similar as well if you're using a transmitter that's got built-in ELRS capability. You'll just need to pick that transmitter instead of picking the module when you are setting up the build for ELRS and updating it. But I'll be using my TX16S radio, which has one of the Happy Model Pro modules in the back there. The Happy Model transmitter that I have is the ES24TX Pro module, which can go up to 1 watt in output for ELRS, but you don't need that much power. Some of the longest range results that have been recorded with ELRS are using very low power levels in comparison to that. So whatever you choose, don't worry too much about the maximum output power level unless you're really trying to stretch things out beyond line of sight range. Okay, so the first thing that I'm going to do is grab the Express LRS Lua script and download that directly to my radio. So I'm here on the expresslrs.org website, making sure that I'm in the version 3.0 section, and I'm going to just right click on this link and save as, and I'm going to save that directly into my radio's SD card in the scripts/tools folder. Okay, so the next thing that I'll need to do is download the Express LRS Configurator. So I'm going to do that, again, making sure that I'm on the 3.0 version of the page. I'm going to click on the download link and then find the version of the ELRS Configurator that will work for my computer. So I'm on a Mac here, and I'm going to grab this DMG file. Now that my download is done, I'm going to click on that file to open it and drag it into my applications on the Mac, or you can install it as appropriate for your system. So next I'm going to navigate to where I just installed the configurator and open it. And on the Mac, I'm going to need to hold down Option and click Open. And then that will give me the opportunity to run this rather than just get caught in the security check here. Okay, so now that I'm in the Express LRS Configurator, we can talk a bit about what this does. So the ELRS Configurator lets us pick which version of the ELRS firmware that we want to be using. Until now, I've been using, I think, the 2.5 version, but I'm going to use this opportunity to update to 3.0.1. And I'll need to do that on my transmitter module as well as on all of the receivers that I'm going to be using. You can choose the version in this drop down here. Usually it's a good idea to go with the latest stable release, or maybe you want to run one version back. It can be worth looking at the release notes to see if there's any particular problems or things you might need to know about a particular version of the software and how it relates to your transmitter or the module or receivers that you're using. So down here in the target section of the configurator, we can choose the device that we want to build a version of the firmware for. So I'm going to go into device category here and find Happy Model 2.4 because that is the transmitter module that I'll be using, and then under device I'm going to look for exactly the device that I'm building for here. So for me, I've got the ES24TX Pro series, so I'm going to choose that option. Next, you can choose whether you would like to use UART or Wi-Fi for flashing your device. In this case, I'm going to select Wi-Fi. And it's going to be important to note that we will need our Wi-Fi connected to our regular home network while we download and build. And then when we're actually wanting to flash the firmware to our modules or receivers, then we're going to need to connect directly to them. So we'll be switching over from our home Wi-Fi network over to the network generated by the transmitter module. There are some extra options down in this section where we can set a binding phrase. One of the really nice things about ELRS is once you've got your module and receiver set up with the binding phrase, that's all they need. There's no further binding required to connect a transmitter and a receiver together. So I'm going to put in a custom bind phrase here. One other thing that might be useful to do is to enter in your home Wi-Fi network name and password. This will mean that in the future, you can just have your transmitter module or your receivers connect to your home network, and then you don't have to switch away from your regular home network to their individual networks. You can just access them directly via your same regular home Wi-Fi connection. So you'll not have anything in here by default, but it can be a good idea to put in your home Wi-Fi network name and password to make connecting to your devices easier in the future. So I'm going to do that now. So one more configuration option that I'll need before I proceed is to choose my regulatory domain. For me, that's going to be ISM. So I'm going to choose this option. So now that I've entered those Wi-Fi details and put in my binding phrase, next I'm just going to click on build. We're not going to click build and flash for that reason I mentioned before, that we're going to need to switch Wi-Fi networks before we actually try and flash onto the device. So I'm going to click on to build, and this is going to download and build all of the components needed to generate the firmware for our transmitter module. This can take a little while, especially the first time that you do it. Okay, so next we're just going to make sure that our transmitter module is running. So I'm going to go into my model setup and make sure to choose external RF and choose CRSF for Crossfire. That'll make sure that it powers up. And then I'm going to go into Tools and run the Express LRS Lua script that we put onto our transmitter before. Once I've done that, I'm going to go scroll down to the Wi-Fi connectivity section and choose the Enable Wi-Fi option. Okay, so now that we've finished building our firmware, I'm going to connect to the Wi-Fi network that we just created. So I will switch over from my home network to Express LRS TX, and the password will be Express LRS. Then again in my browser, I'm going to go to 10.0.0.1 to the configuration page for the transmitter module. Then I'm going to go to the update section, click on that, and then I'm going to select the firmware file that we just created, drag that in, and click update. Okay, and as directed, we'll give a few seconds while the transmitter module reboots, but we've now successfully updated the ELRS firmware for our transmitter module. Next, we're going to update this upper board, which is the ELRS receiver. So we're going to do that in a quite similar way to how we updated the transmitter module. So the first step is to connect power to your PWM board. So you'll just need negative and 5 volts, or negative and hooking up to the VBAT section. The other thing that's important to note is there's a lot of information on the Matek site in these various tabs. Sometimes not necessarily in the tab you'd expect to be looking for. The relevant point here is that when we're flashing the 2.4 GHz receiver, the ELRS receiver, we need to use the DIY 2400 RX firmware that's listed here. So we're going to build some firmware now for our receiver and making sure to pick this one from the list. So I'm going to show you how you can do that. I'm going to go back into the configurator. We're picking device this time. We're going to be picking DIY 2.4. And then I'm looking for that same one I just saw on the Matek site. So that's this one. And just double check that. Okay. In this case, we are also going to use Wi-Fi flashing. We're not going to flash immediately here. You need to make sure the binding phrase is the same, otherwise you're going to have a hard time binding. And again, I'm going to enter my home Wi-Fi, SSID, and password, or check those options at least. That has remembered those details. Then I'm going to click build. So this will now download all of the required pieces to build the firmware for our ELRS receiver. Okay, so that build went well. We've now got the firmware that we need for our receiver. So again, like before, we just need to make sure that we switch over our Wi-Fi network, and we're going to select Express LRS again. And there we go. This time for the RX, and password is Express LRS. Okay, so once that Wi-Fi network is connected, I'm going to go to that same 10.0.1 page. We can see here the current firmware version that's on the receiver. And I am going to, again, just grab the file that I just created, making sure that we're looking at the one for the receiver and not the one that we previously created for the transmitter, or that will cause us problems. And I'm going to choose that file and update the receiver. Okay, so for the next steps, you will need a USB to TTL adapter. These are somewhat generic, so long as you've got something that looks mostly like what I've got here, USB on one end with some outputs for TX, RX, ground, and 5 volts, then you should be good to go. We're going to use this to communicate with the lower board, the PWM converter. We're going to use this to update the firmware on the PWM converter board. There are a couple of reasons to do this. The main advantage of updating this board from a gliding perspective is that in addition to variometer, you'll also gain the ability to get altimeter telemetry. You may also be able to make some other changes, such as the number of channels that are active on the receiver using the TTL adapter. It can also be useful for double checking things like your failsafe and the function of the telemetry, and you can also use this same adapter if you are ever running into issues with one of your devices. If you manage to brick one of your ELRS devices so that the Wi-Fi is no longer working, you can potentially use this device to directly wire it into your computer and try and fix it. So you can see the way that I have wired the TTL device and the PWM board together here. What I do is just use this row of jumpers kind of sitting in their holes but not soldered in place. The connection when kind of held in with a thumb is good enough that I haven't had any problems while updating. If you want to be sure and you want to eliminate all sorts of potential problems, then maybe just soldering these wires into their place is the better way to go. But I've now done 3 or 4 of these receivers and updates and haven't had an issue updating them this way. One important thing to note when you're wiring up the TTL device is that the TX wire from the TTL is going to need to go to the RX pin on the receiver and vice versa. The RX pin on the TTL device is going to go to the TX pin on the receiver adapter board. So the next thing to do is download the Matek Configurator tool. You can find this on the CLI and parameters tab of the product page for this receiver. Once you've downloaded that software, also make sure that your USB to TTL device is recognized by your computer. If not, you might need to install the drivers for your TTL device as well. So I will link those in the description or on the screen at this time. By the way, I should also mention that the Matek Configurator is only available for Windows and only for the 64-bit versions of Windows. So you'll notice that I've switched to a Windows machine for these steps coming up. So once you have downloaded and run the configurator, it will look something like this. Select the COM port and click Connect. And if that's working properly, you should see a message like this on your screen. You then want to make sure to open the firmware file for the firmware version that you're trying to update to. So in this case, I'm updating to V2.3. So I've picked the firmware file for that, which is included with the configurator. Then I've clicked Upgrade, and we'll see that that upgrade is in process. So once that's all done, you should be able to go down to the command line interface at the bottom of the screen and type in version to get the version of the software that's now running on the PWM board. If you type in help, you can see the other commands that you can run from the command line interface there. So things like getting the barometric data like altitude can be done directly from the command line as well for testing, and you can see the other settings on screen. So now that we've done all those different types of firmware updates, let's talk about how you can wire up the receiver for normal use. Probably the simplest way of wiring up the receiver is just to connect the positive terminal of your battery to VBAT and the negative terminal of your battery to ground. So you might want to run a little jumper wire off of these pins and to a convenient place with a connector for your battery, or however you normally have your battery set up for your receiver. The way that I typically wire up my receivers is a little bit different though, because I've got quite a tight install. I'm sticking this whole receiver under the servo tray on a BAMF 2, so I prefer to just have all of my connections to the receiver going through the pins because they are what's facing forwards and what's accessible to me. So I actually just use 5 sets of pins and chop off the other one to give myself some more space. And 4 of those I use for servos, and 1 of those sets of pins I keep and use to plug my battery directly in with a servo connector on the end. If you're wiring your setup this way and using a 1S battery, what you'll also need to do is connect a wire from the VBAT connection on the bottom of the board to one of the 5-volt pins on the row of PWM pins there. So you can see I've done that in the channel 7 space because I don't have anything there, but that could go to any of the 5-volt pins along that section. And that's going to provide that voltage telemetry to your transmitter if you wire it up that way. Okay, so next let's take a look at how we can set up the telemetry on the radio and just verify that everything's working. So I'm going to take my receiver and in my case I'm just going to be plugging in this 1S battery straight into one of the sets of PWM pins here. Doesn't really matter which one I plug into at the moment, so I'm just going to plug in like this. Okay, we can see that that is powered up. I've already got my Crossfire external module selected as shown earlier in the video. The next thing that I'm going to do is go into the model button here and scroll over to the telemetry window, and then I'm going to click on Discover New, and that should pick up all the various telemetry that we can get from this receiver. So if I move the receiver here, we can see that the altitude is changing. The battery voltage is also showing up for my receiver on the screen there. So that's all looking good. Let's check for Vario. 3.9 volts. It sounds like the low battery setting on my radio needs some adjusting. But yeah, we can also see vertical speed is there and quite sensitive to change as I move the radio as well. So one of the things I'm going to do next is take a look at some of the settings we might want to adjust as well for working with our ELRS module. So I'm going to go into the system settings, Express LRS, and here you can adjust the packet rate. So a faster rate will have faster response to your inputs of your sticks. A lower rate here will have a slightly better signal. So you can adjust that down really low if you're wanting to try and get the best distance possible, but probably not relevant for gliders. Really, most of the power of ELRS isn't needed for actual distance in gliders, but it's often the carbon fiber wing and the carbon fiber fuselage can actually act as a pretty good signal blocker. So we're just trying to get the best signal and connection with our glider that we can. So the telemetry ratio setting here will adjust how often a packet of telemetry will get sent compared to a packet of signal. To be honest, I just adjust this until I like the way that the Vario sounds, so that I get a good number of Vario beeps without it being too slow or too annoyingly often. But you can set this telemetry ratio and experiment with it to suit yourself. You may also want to look at some of the power settings. Obviously check your local rules about what is okay for radio power. But there is the facility here to use the dynamic function and then set a maximum power level. So your radio will operate at the lowest reasonable power level that can maintain a signal, but then will increase the power output as needed to make sure that that signal stays strong. The fan threshold here is going to tell the radio at what power level the fan on the back of the radio should kick on. So that's kind of like your first warning, I suppose, that the radio has started kicking up the power level to maintain a good signal. So I'm just going to leave these settings as they are at the moment. I don't recommend increasing the fan threshold because then the module is going to get more hot more quickly. Okay, so now we're on to the most annoying thing about this receiver, I think, which is setting the failsafe position. It needs to be done with a physical jumper between the signal pins of channel 1 and 2, like this. Then when you power up the receiver, the first signal that it receives is going to be set as the failsafe position. So this takes kind of 3 hands. I'm going to need to pull the throttle stick back to the flap position, full flaps that I want to have during a failsafe, and then I'm going to pull left as well for left rudder. While I'm holding that, I'm going to connect my battery to the receiver here. And we'll see some flashing lights going on. I'm going to wait for this blue light to flash through a sequence of its signal, and once it does its multiple flashes, we'll take that failsafe position. Then I'm going to disconnect that jumper that I connected, and now my failsafe should be saved in the radio. Always double check your failsafe position by turning off your radio while the receiver is connected and powered up, and make sure that your servos go into the position that you expect. So that's just about it. Hopefully that gives you everything that you need to get started with using your Matek ELRS receiver and PWM board. It is a pain going through all of these different firmware updates and this very clunky failsafe setting acrobatics, but the signal quality is fantastic, and yeah, I felt fully confident in the signal strength of my gliders everywhere that I've been flying ever since I did this. So this is why we do all this, so that we can have really nice, strong signal, hassle-free performance, even with a big carbon wing and carbon fuselage potentially blocking some of the signal in some orientations. So hopefully this has got you going and gives you all the information that you need. If you've got any questions, pop them in the comments below and I'll do my best to help you out. Thank you.